Cheers.
So this is Team 3317 from Columbus, Indiana, Columbus North. And the very first question of the Moody's Mega Math Challenge is, what is your name?
My name's Christopher, aka just Chris.
My name's Tushar.
My name is Brian.
I'm Byron.
Great, welcome Team 3317, and you may begin.
Thank you.
Is this the clicker?
I think that's the clicker.
Ah, that looks like a clicker. All right. Hello, everyone. Thank you for your time. We are team member 3317, Columbus North High School, and today we'll be discussing our solution to helping schools and governments get a good school lunch to their students. That's never a good sound. Okay. All right. So around the nation, 32 million students get lunch from their schools, so that's more than the population of Texas. Obviously, with so many people to feed, three interest groups have emerged with very different goals for what they want in school lunches. Students prioritize taste, schools need meals to be affordable, and the government wants meals to be nutritious. So with limited resources available, these interests are very difficult to balance satisfactorily. So our team was given three tasks. Firstly, we need to create a model that can accurately calculate an individual student's caloric needs. Secondly, we need to determine the proportion of high school students across the entire United States to get enough food for lunch. And thirdly, on a limited budget, we were supposed to create a school meal plan that would adequately meet students' needs. Throughout this paper, we'll be making two global assumptions, the first of which is that the population of students with special dietary needs, such as vegetarians, is insignificant. And secondly, that the data we have obtained is accurate. Both of these assumptions were made for the sake of simplicity.
Before we dive into the three parts of the problem, we first wanted to analyze the impact of geographic variation on caloric needs. And so the reason we did this is because the United States is composed of 50 different and diverse states. What works in California may not work in Rhode Island. What works in Rhode Island may not work in Colorado. So to accomplish this, we looked at a database entitled Census at School, and we pulled samples of 200 students from the US and from each of 7 states, and looked at the variables of average hours of sleep nightly and average age. We chose these two variables because they will appear in our model, which we will introduce shortly. We did a t-test for the difference of means, and so our null hypothesis is that the difference between average hours in sleep in the US and average hours of sleep in any of the 7 states is 0. We checked the conditions for inference and all of them were met. And we calculated our p-value using an alpha level of 0.05. Because p was greater than alpha, we did not reject the null hypothesis. We did not find a significant difference between average hours of sleep in the US and in a certain state. We repeat this process for average age. And so you can see the null hypothesis is similar. Once again, using a p-value, using an alpha level of 0.05, p was greater than alpha, and we did not reject the null hypothesis. On this map, you can see the 7 states we used. You can see Texas, West Virginia, Connecticut, etc. And so we believe these 7 states, which were randomly selected, to be representative of the United States as a whole. You can see that they're in different regions of the country. They have different populations, incomes, demographics, etc. And so to conclude this, we found that factors such as average hours of sleep and average age are independent of geographic location. And we can safely exclude geographic location from our model that we will introduce shortly as a potential lurking variable.
So one of the major things our team was tasked with was creating a model representing students' caloric needs. Going into this, we made a few assumptions. First, that students would always attempt to eat 3 meals a day, and that students would always receive and eat dinner. We made this assumption in large part because the proportion of students who actively avoid eating is 0 or very nearly 0. We also assumed that calories spread evenly across meals. Although this wouldn't always be the case, we assumed this because we're working with an ideal situation here. We assumed that eating breakfast and being below the poverty line are independent from each other. We make this assumption because more often than not, eating breakfast in the morning is more of a situation due to time than the actual cost of eating breakfast. And lastly, we assume that all students will eat 580 calories of snacks per day. We make this assumption as a flat amount instead of a scaling amount because snacks usually come in pre-packaged segments instead of portions that you can pick and choose from. So our approach was to break the model into large pieces. These pieces will go into greater detail later. Firstly, we had a function representing basic functioning needs, and then we added an increase in calories from sleep deprivation. We then subtracted calories consumed to snacks, and divided by 3, and then multiplied by a ratio based off the frequency breakfast is consumed. Lastly, we added an increase in calories at lunch due to poverty. And more in depth, our first formula was a function based off of age, physical activity, mass, and height. We pulled this function from the website given to us with the problem, and we used the equations from the 9 to 18-year-old segments, and then used the male and female versions. We added to this a formula based off of the amount of hours you get per sleep per night. We believe that sleep deprivation is a fairly common problem for high school students, and so we figured it was a reasonable assumption to include. Lastly, we subtracted 580 calories from the total calories needed per day. This gives us the amount of calories you need from all your meals in the day. We then divide by 3 and multiply by a ratio based off the frequency breakfast is consumed. To give an example of this ratio, if you ate 100% of your breakfast, you would multiply the equation by 1, which would divide the equation by 3 to get divided across 3 meals. And if you ate 0% of your breakfast, then you multiply the equation by 1.5 to get the calories spread across 2 meals. Lastly, we then added 200 extra calories if you were below the poverty level. We make this assumption because we believe that poverty Americans would be requiring more calories from their lunch, and we choose 200 calories because it's about 25% of a normal student's lunch. So these are our final models. Given the fact that they had 7 variables, we decided it was probably a good idea to do some stability analysis, which my teammate Tushar will be going over next. Thank you.
The question we were trying to answer with our sensitivity analysis was, can students change their caloric needs? And so some of these variables, such as age, weight, and height, are out of a student's control. Others, namely these 3, physical activity, time spent sleeping, and breakfast frequency, are in a student's control. And so we held the variables constant at what we found to be average values, with the exception of age, which we chose at 18 years, and considered a function of just these 3 variables. We used partial derivatives and found a linear approximation to our function of 3 variables, and then estimated the average effect on the outputs of changes in the inputs. So what you see is that a change in the physical activity level of 0.1, which represents a moderate increase in physical activity 2 to 3 hours a week, results in a student needing, on average, 106 extra calories at lunch. A change of -1 for T, which means 1 less hour spent sleeping per night, causes a student to require, on average, 62 more calories at lunch. And lastly, if the student eats breakfast 10% less frequently, then a student will require 32 more calories at lunch on average. We then conclude that our model is reasonably stable with respect to its inputs, but students' caloric needs can be changed if necessary.
For the next part of our report, we were asked to determine the proportion of high school students across the nation that get enough food for lunch. So for this section, we made 3 assumptions, which is first, that the average school lunch contains 825 calories. This is based on values found in our research. Secondly, as per our findings in the first part of our paper, all factors except income are independent of our location. And thirdly, that our large sample size of over 2,000 students is sufficiently representative of the population. To approach this task, we wrote a program that accessed survey data downloaded from the census at school and ran it, along with weighted, randomly generated parameters, through our equation from part 1 to determine the mean caloric requirements of the student population. We then calculated the proportion of students that were satisfied by an 825 calorie lunch and created a 95% confidence interval. We repeated this for each of the 4 regions of the United States and for the nation as a whole. So here are our findings in chart form. There was minor variation between regions, but in general, just over 50% of the high school students in each region got enough food for lunch. The best performing regions were the Northeast and the West, with the worst performing region being the South. Here's a histogram of our findings. The green portion here represents the proportion of students that get enough food for lunch. To determine how stable our estimate was with respect to L, we ran L, which is the number of additional calories required for students in poverty, at other values. This is the distribution for L equals 100. Predictably, the distribution shifts to the left and the proportion of satisfied students increases since we have reduced the number of calories impoverished students require. This also holds for trends in different regions. This is a histogram of the national distribution. Again, the green area represents the proportion of satisfied students. Finally, we ran it for L equals 0 additional calories for students in poverty. Now that we're not taking the poverty rate into account, this is a distribution for each region as well as the national distribution. And we find that about 55% of students get enough food for lunch. However, this is only a change of a few percentage points from our initial findings, so we conclude that our model is stable with respect to L. So in conclusion, we find that slightly over half of all high school students get enough food from their lunch. And there's plenty of potential for further research with this, such as how we can economically increase that proportion, but for now we content ourselves with identifying the status quo.
For the third part of our problem, we were asked to create sample school menus and some down arrow.
Yes, down arrow.
Right there, this button.
There we go. Thank you. Two assumptions we made in this section were that students eat the entire meal given to them. We made this assumption because this is not controlled by anybody but the student. And a second assumption we made was that a food from each food group ensures a balanced meal. With these meals, we had to do three things, which was to create a nutritious, affordable, and delicious meal. And we had to do it on a budget of $6 per student per week. We had to provide approximately 825 calories per meal, and we had to include a food from all 5 food groups. And also, the students had an option to get a dessert, which makes it delicious. To do this, we created a program that created students that pick random items for each meal, and then also had an extra item they could choose that could either be a dessert or another item that they could like. And if the cost of the meal was less than $1.20, then to output it as available meal. On the right here, there's a picture of the program. It spits out the various numbers that for each meal is, and then the total, the average, and then whether or not it is within budget. And as you can see, here are some meals that were spit out. And as you can see, they're very different and can apply to a wide range of students. Some numbers we got with various sizes in schools for 1,000 and 2,000 students were not very varied, so we figured it would be very stable for either sizes of schools. And also we were asked what could happen if the budget was increased to $7 a week, and we said that it could increase the variety of foods, the quality of foods, a mixture in between. However, this does not fundamentally change the problem.
We would lastly like to conclude by answering the question asked directly. Is it possible to be nutritious, affordable, and delicious? So first, we analyzed the impact of geographic location on variables such as average hours of sleep and age. And we found that geography does not significantly impact them. We left out geography from our model then, with the exception of socioeconomic status. We then modeled caloric needs based on a student's individual attributes, such as age, weight, hours spent sleeping, frequency with which they ate breakfast, and others. Our model was reasonably accurate and stable with respect to its inputs. We performed sensitivity analysis with respect to physical activity, time spent asleep, and breakfast frequency, and then later with respect to the extra calories for impoverished students. We found that the school lunch meets the needs of approximately 50%, slightly more, of students in the United States. And a small increase in caloric content of lunch would yield a disproportionately large increase in the number of students whose needs were met. Lastly, we created sample school menus for schools to use. A lunch budget of $6 per student per week is indeed sufficient to provide balanced and appealing meals to students. So the overarching answer to our question then is that it is indeed possible to be nutritious, affordable, and delicious. Thank you for your time.
With regard to the questions that you addressed early on about geography, so it seems like maybe the first thing you did was check to see whether high school students are the same age in every state, and we can check that one off. It seems that that's the case. But it seems like maybe there are things that would vary state to state, activity levels, or maybe the types of foods that students in California eat are different than the sorts of foods that students in Georgia eat. So are there any of those things that you feel like you missed?
That's a very valid concern, and when we looked at the Census at School database, we used the variables that were provided to us in that database. While it was quite extensive, it didn't include the foods eaten, for example. And so basically this was a problem with using the data provided to us and using the data that we could find. Yes, I think it would be safe to assume that geography causes slight increases or slight decreases in certain variables in certain states, but then the other aspect of this, that it may not cause significant differences, and especially when you consider the 50 states, it may average out to the nationwide mean.
Okay. You had two separate equations for the caloric needs for males and females, but in your sensitivity analysis, you said that the female caloric intake would be similar to that of males. So you didn't do any further sensitivity analysis for the females? Could you justify that they're similar?
The models for male and female are essentially the same, with the only difference is due to biology, and so that's the difference in the basic functioning needs for students. Factors like poverty or snack intake were constant for both males and females. So basically there wasn't a big difference between the two models, and what we found for males would apply to females.
In your random selection of 7 states, you completely ignored the Southwest. Did you worry about that?
Could you repeat the question, please? We ignored the South, you said?
Oh,
Southwest.
You had
Southwest.
7 random
Yes.
states that are representative, but none of these are from the Southwest. Did you worry about that?
Well, it was a concern, but with the sample of 7, the map will appear in a moment. With the sample of 7 states, we felt it was sufficiently representative. We had Texas, which is pretty representative of the South. What you could argue that states.
But it's not representative of the Southwest.
Right, and so I guess you could say that a bigger sample size would have been more helpful in determining this, but we just contented ourselves with the 7 states.
So, okay, you were satisfied with that.
they were picked out by a computer and not by
Correct.
us.
Mhm.
Additionally, we can see at least that this is representative of the states or the regions that we analyzed. There is the Northeast, which is represented by states such as New Jersey, I believe, the Midwest, the West, and the South. Each one of those regions has at least one state highlighted on this map.
Yeah, I guess my question was simply whether you questioned that random selection.
Well, we did question it, but it's random, and so that could happen. So, yes.
Yes, I have a question on the last part of your model, right? So we're talking about the types of meals that you're actually presenting to students, and in fact, I thought the variety of meals you had was really impressive. But it seemed as though you were really bumping up your satisfaction scores by incorporating tasty desserts, right? Was there any concern that that's going to lead to they're just going to eat the dessert type of problem? And how could you combat that if you were to improve your model, or does that lead to improving your model?
The dessert is all up to the student. They had the option of not choosing a dessert at that end, but they're also choosing another healthy item from one of the 5 food groups. And I believe 2 or 3 of those sample ones we showed up there, the student did not choose a dessert. They chose a food item.
Additionally, one of our simplifying assumptions was that students would eat the entire meal provided to them, just simply on the basis that they had some choice in the matter. It's unlikely that they're going to pick a meal that they don't want, and also is something that's just outside of our control.
Well, let me ask a follow-up question. Did you give any thought to vegetarian lunches?
That was one of our global assumptions.
One of our global assumptions was that we'll consider that population to be insignificant.
Okay.
We found that the proportion of vegetarians is around 5%, and we considered that borderline to something that would be significant, but we decided to ignore that for now.
Do you have any other assumptions that in the 7 weeks since the challenge that you might want to change?
I think that the assumptions we presented are accurate of what we assumed during the actual paper writing process. One that we didn't include in our paper, but we included here, was that data obtained is accurate, which, I mean, that's an obvious assumption. We have to assume that what we're doing is based on true data.
Thank you.
Thank you.